Today we're adding two different weapon types to our weapon system. We're going to be adding a Hitscan weapon type and a projectile weapon type. Working from the last episode, we have our weapon resource script, and we're going to be adding a couple things here just to get started. The first is a isHitscan boolean, and this is how we're going to determine when we create a weapon, whether that weapon is a raycast weapon or a projectile weapon. We can add that right under our max ammo. It's just another export variable within our resource, isHitscan boolean, and we're going to set that to true as the default. Now, if we set that to false, then we're going to be using a projectile weapon, and to do a projectile, we need to have a scene for that projectile. We've done the same thing for our weapon model here, and we're just going to add another export line for our projectile scene, and that's just going to be another packed scene that we can load within our resource. And once you fire a weapon, we need to know how far that weapon can fire. And for our hit scanning weapon, that's going to be using range. This will be another export variable that we add. Again, this is the beauty of having a weapon resource that we can just add to. Everything's going to be self-contained within these, and it's going to be really easy to edit. Let's set a default range of, let's say, 25 meters. That's as far as that raycast is going to check. And for our projectile scene, we can also use the range if you want, but we're just going to use time to free our projectile. So if the projectile doesn't hit anything within a certain period of time, we're just going to get rid of it. This should be what you have now within your weapon resource script. And now that we've got that, we can actually implement our hit scanning. We're going to be going to our weapon controller script that we've been working on and make a couple of adjustments here. We're just going to do a nice, quick and easy export variable up here in our weapon controller script for our camera 3D. We'll save that, go ahead and assign that to our player's camera. And now that we have access to that, we can create our hit scan function. This camera is important because it's showing what direction we're looking in, and we want to fire obviously in that direction. So we need access to the camera, and then we're going to shoot that raycast out from the center of that camera. In our weapon controller script, we're going to add a new function after our fire weapon function, and this function is going to be our perform hit scan function. I'm going to copy what I've got in the finished project, and then we're going to take a look what we're doing here. Go ahead and comment that out. So we're going to perform a hit scan. First, we need to check if we have assigned our camera. If we don't have a camera assigned, none of this is actually going to work. So we need to return out of this. Then we're going to get our space state, a from variable, a forward variable, and a to variable. So whenever you're doing a raycast in GDScript, you've got to get the 3D space that you're working in. And that 3D space is coming from our camera. So we get a reference to the camera, we use the getWorld3D function, and then the direct space state property. This just means that we're working within the same physical space that our player is in, that our camera is in. Our from position is going to be the origin of our camera. That's when we're going to start our raycast, and then we're going to go forward, so the forward direction, which is our global transform. Remember, forward in Godot is -z, and then our to. So our to is going to be our from position plus our forward position times our range. And that's going to give us that line. Say we're doing 20 meters ahead. In fact, I can show that going here. So say we're doing 20 meters. That's going to go all the way out in that direction. And that'll be where we are testing our hit scan along that path. Go ahead and change that back because we don't want to be able to interact with stuff that's 20 meters away. Next, we do our query, and that's going to use a physics ray query parameters 3D object. And it's just, you create it and you do a from and a to, which is why we created those things, and we get the results in our space state. If we get a result, we're going to print something. We're going to get the result for the collider name, what we've hit, and at what position. And we are going to make a little impact marker so we can visually see what we're shooting when we test it. Let's go ahead and uncomment that. I'm going to add in my spawn impact marker function here. And all this does is it's going to spawn a box. It's going to spawn a box at the position that we've hit. We're just making a new mesh, making it set to a box, making it small, and then we're just setting the material to have a red color so we can see it. Once we've done all of those settings on the box, we're going to add that as a child to our current scene. Get tree current scene, add child, add our marker, and set its global position to the hit scan position where we have shot that we're passing along through our results position up here. And then finally, just a way to remove it after 2 seconds. We can actually test this right now. All we have to do is go up to our fire weapon function that we've set up. So if current weapon, remember we added this, is Hitscan. If it is, let's perform our Hitscan. And else, which we haven't done yet, we're just going to pass this for now. We're going to do our spawn projectile. And that's how we're differentiating between our raycasts and our projectile setup. We fire, get our cube, we have our ammo going down. We're shooting an invisible line from the weapon, although technically it's from the center of our camera, our reticle. Now, one thing to note is if you're having issues getting something to hit, you might need to check your collision masks. This is basically checking everything right now, but you can select what you want it to be able to hit by going into your query and then selecting a collision mask. Right now we're hitting everything that's the environment, our first layer. So our value is 1 at least. What we can do is let's set this to a value of 2 just to test it. And what this will do is it means if we hit the environment, it won't actually do anything. See, we're not getting our boxes anymore. So you can set this to hit the environment. Maybe you only want to hit enemies, but that's how you do that. We've got our hit scan working. Next, we can create our projectile system. We're going to create a new script within our weapons folder here. I'm going to call this our projectile, and this will just be a base projectile. Because you might have different types, obviously. You might have a grenade, different things that interact in different ways. This is just going to be sort of like a laser that gets shot out. We're going to open that up. We'll obviously add a class name for this. We'll call this projectile, and it's actually going to extend an area 3D. Now, if you're trying to do a rigid body, that might be the thing that you think of. Like, I'm going to shoot a physics object, and it's going to be a rigid body. Or I guess really an animated body if you wanted to move it manually. But there are issues with that in that sometimes it can move so quickly, your projectile, that it doesn't register. And you're going to have issues with projectiles hitting things consistently. The solution to that is to actually make the projectile an area. We're going to add a couple of variables here. We're going to have our velocity. That's how fast and in what direction our projectile is going to move. And then the amount of damage that it should have. So next in our ready function, first we need a way to know that the projectile has hit something. And we're going to use the body entered signal that is within a area 3D and connect that to a function of our own. So we have body entered, connect, and then we haven't created this yet, but on body entered. And then like I said before, we're not using range to sort of clean up our trash here. We're just going to add a timer, and as soon as the timer times out, and we're going to do just 3 seconds here, then we're going to connect that to our queue free. There we go. So we'll fire the projectile after 3 seconds. Projectile doesn't hit something, it's gone. Then within our physics process, so every physics tick, we're going to change the global position of this projectile by our velocity times delta. When we spawn our projectile, we need to set up a couple of things, and we need to set up the velocity that we added up here, and we need to set up the damage. So we're going to get that from our weapon controller. So this will be a function that we fire from within our weapon controller, and we're going to pass along our velocity and our damage. And then all we need to do is set our velocity to that and set our damage to our parameters. And now we can add our on-bodied function that we added up here. Nothing fancy here, just on body entered. We're going to print the projectile hit this body at this position. And when we hit something, we get rid of the projectile, obviously. And that spawn impact marker is the same exact function that we already talked about. So spawn impact marker, create the box, set it to red, add it to the scene, set the position, get rid of it after 2 seconds. Now we need something to attach it to. So we're going to create a projectile scene. And if you remember, in our weapons resource, this is what we load in our weapon resource. So go up here, we're going to create a new scene. And for this, we're going to do other node and use an area 3D like we talked about. Go ahead and call this projectile. I'm going to add a child to this. This is going to be a mesh instance, and you can just do a sphere, whatever you want to do. I kind of like to do a capsule. just to make it look like one of those Star Wars lasers. There we go. Then we need to add a collision shape. We can just use our mesh button up here, create collision shape. We'll make it a sibling and then a single convex. Head down to your script setting and we're going to load our projectile script to that. And let's save this scene. We'll go to our scenes, weapons, save that. And then like we talked about, we got to add this to our scene. So we've got a pistol weapon that we've set up and currently it's Hitscan because we set that to Hitscan. Let's turn that off and let's load our projectile. And this is actually a really good way to show how quickly and easily you can change this. So we've set Hitscan to false, which means we're going to be a projectile, and then we've loaded our projectile scene. While we're in here, we need to add another setting for our projectile. So Hitscan is immediate, projectile takes time, so we need to know how fast the projectile should move. We can do that by adding a line for our projectile speed as a float, and we'll set that to 50, and we'll see how fast that actually looks. And then the last thing we need to do is go back to our weapon controller and add our spawn projectile. So in our fire weapon function, we are checking for that hit scan. We're performing a hit scan if it is, and else we're passing. So we don't want to pass, we want to spawn projectile. We want to spell projectile correctly. It is so hard to type and talk while also reading your own notes about what you're trying to teach. So spawn projectile, we'll run that. Obviously we don't have that yet, so let's put that in here. So I'm gonna paste this in here and we'll go over it. So we're gonna spawn our projectile. We're gonna check if we actually have a projectile scene. If we don't, then there's no point, let's return. Check for our camera. If we don't have that, let's return. Basically, we're spawning that projectile scene that we created, adding that projectile scene to the tree, setting the global position. Here I've set this just to the camera position. What you're going to want to do if you've got your weapon figured out is go into your weapon and you're going to add a marker here. I won't go over this, but we'll do this in another video. You're going to add something that you want it to spawn from. You don't want it to necessarily spawn from the center. For now, we're just testing, so we're going to spawn it from the camera position. Forward is the forward position from the camera, and then the velocity is that position times our projectile speed. And then remember, we had that setup function in our projectile script, and we needed to pass that velocity, and our damage amount is coming from our weapon resource. We can save that and we can test it. So we should fire and we should have our projectile fire out. Now you're going to notice two things that people almost always run into when they first try to do this. One, the projectile is not coming out in the right direction. It's turned. And two, we're actually not hitting anything. So let's fix the turning thing, because that's a pretty straightforward fix. We're spawning our projectile, but we need to actually point the projectile in the direction that we're shooting. So let's go back to our weapon controller where we're spawning this thing. We're going to take our projectile and use the look at function. And this is going to turn the projectile in a direction that we set. And that target is going to be the global position of the projectile plus our forward position. Then we need to set this to vector up, just so we understand what our orientation is, and that should fix our direction issue. Now to fix the collision issue, we're shooting this area 3D, and I already talked about the fact that a rigid body 3D isn't going to work very well. The area 3D will work if you're moving slower, sometimes if you're moving too fast. The best thing that we can do is actually fire another raycast. That means whenever we create this projectile, every frame, we're going to check in front of this projectile if it's going to hit something. I found that this gives the most reliable collision detection. It's pretty easy to add. So if you go into your projectile script and your physics process function, we're going to add some lines here. We'll get rid of this and we'll do our raycast. So we're going to get our world space and we'll get our start position, which is the global position of our projectile, our end position, which is the global position plus the velocity that we've set times delta. That just means how far this is going to be moving within that one frame. That's why we're multiplying by delta here. And then we'll do our query. Again, you can set your collision mask. We're going to make sure we can collide with our environment. We do our intersect array and we get our result. Then if we get a result, we're going to set the position of the projectile to wherever we hit, and we'll run our on-bodied entered, which lets us know we hit something. If we don't hit anything, then we just want to move it to where it would have ended up anyway, which is that in position. So we can test it now, and we'll shoot our projectile. And maybe it's a little fast. I can slow it down. Shoot our projectile, and you notice that we get our cube there, and we're also getting a print of what we hit. And again, this is the most reliable way that I can show you in a quick tutorial like this to make your projectiles like work and not bug out. And as we move forward, we're going to be adding some more polish, some more juice to this, and really flesh out this weapon system. So thanks for watching. As always, you can get the source files for this now on my Patreon. I've got a link to that in the description. We're going to keep moving through this. I'm going to get the next episode out as quickly as I can. And thanks for watching, everyone. It's fun to walk through this stuff and to talk about it. So I'll catch you in the next one. And as always, keep creating.